I'm going to grab the screen. Oops. Can everybody see my screen?
Yes, yes.
Yes.
Okay, everybody, students, welcome to our meeting number 12 on our curriculum and our schedule. This meeting is another one in our series of virtual meetings, introducing you to different industries and information related to architecture, construction, engineering. Today's meeting is about construction management. So throughout the school year so far, you've learned about various aspects of the design process, primarily architecture and engineering, different disciplines in engineering. And you also learned about building information modeling. You learned about sustainability. Now we're going to give you a little bit of background on construction management. So myself, Jacob Katz, and Matt Thompson, we are going to do the speaking here and the information that you will see in this class. So I'm going to start first with a very brief introduction here to the world of construction management and being a general contractor. Okay, and some of this information, some of you have seen already from a previous presentation, but it also plays into what we want to show here regarding to construction. So you've heard before, with a project, there's always an owner, and the owner is who initiates that project, and that owner hires both an architect and a general contractor. So on the general contracting side, that's where an individual like myself or Matt Thompson, that you'll hear from in a minute, we work for the general contractor, which is also known as construction management. And then underneath the architect and the general contractor, we all hire a lot of different other companies that are all within the world of architecture, construction, and engineering. Specifically to the general contractor, since this class is about construction management, I want to show you some of the individuals and roles that are involved with working for the general contractor. We often have the office side and the field side of construction. On the office side, we have project managers, assistant project managers, project engineers. We also have estimators. I don't show that on the screen. And then there's other roles on the office side, or different names and different titles that different companies use, but generally fall into that hierarchy of individuals. On the field side is where we have what we call our superintendents, also known as site managers, field supervisors, and underneath them we have assistants. So this in general represents the types of roles and individuals that work on the general contractor side. Now, what I always like to show everybody, and some of you again have seen this already from me before, is I want to show you the kind of money you can make specifically in the general contractor side. So right now, out of college with a 4-year degree, companies like mine, and I know where Matt works, we're hiring individuals anywhere from $65,000 to $85,000 right out of college. A lot of that depends on potentially your age, if you've had other experience before you went to college, if you interned while you were in college. Those are all metrics that could impact how much money you can make getting hired right out of school. And within 3 to 5 years, you can easily grow into a 6-figure salary, making over $100,000. Project managers and superintendents, after multiple years, can make as high as $150,000 or higher. And also, depending on the size and types of projects you end up working on, could also impact the types of salaries you make. Even the locations of where you work, if you're willing to take an assignment with a general contractor overseas or in a unique location, then that could also impact the kind of money you make. And then as you grow in your career and you become an executive within a company, such as a general contractor, you can start making over $200,000 a year. And that can come sometimes within 10 years time frame, sometimes before, sometimes a little bit afterward. So just sharing with you the kind of money you can make, because a big part of our program is we want all of you students to consider eventually going to college to study either construction, architecture, engineering, and then join us out in these industries and these careers. Okay, a little bit more on the type of work that we do as a construction manager, both in the office and the field side. In the office, some of our work involves contracts, both legal language and also more specific to what you do in construction in those contracts. We manage a lot of meetings. Those meetings take place with owners, with architects, and with engineers, and also with our subcontractors, and sometimes with many other entities within the area we're working. We plan and we schedule a lot of activities. We have to be very organized in this business in order to plan and schedule correctly. Matt is going to be speaking about scheduling in a minute. A lot of our job on the office side, a lot of what I do is I'm writing emails and letters almost every day. Well, definitely emails every day. And we collect a lot of money from the owners, and then we have to pay that money out to our subcontractors. And we also prepare estimates. That's all on the office side. And there's many more activities. I'm just highlighting some of the big ones. On the field side, that's where the superintendents work. Superintendents have to be very familiar with the blueprints, the plans, the drawings, and specifications to make sure that the project or the building is built correctly. Sometimes superintendents or people under the superintendents are doing physical work out in the field. There's a lot of supervision of the workers to, again, to make sure that things are being built correctly, to make sure people are being safe and accurate in the field. There's a lot of oversight on the quality of the construction to make sure that a project is not only built correctly, but is built to proper quality so that the owner is happy with the way the project looks at the end. And superintendents also are very involved in getting inspections and approvals. Every project that gets built has a multitude of inspections from a local building department, from specialty inspection companies, and other organizations that are involved in the project that do inspections. And that's a big part of the field's responsibility. The superintendent's responsibility is to make sure that all inspections are obtained and approved. So that's a little bit of background of what we do as a general contractor in the world of construction management. At this time, I'd like to turn it over to Matt Thompson, as I introduced before, and Matt is going to talk to you a little bit about scheduling before I take back over the presentation for some estimating information and also for site utilization and logistics, and I'll explain what that means in a minute. Matt?
Okay, can everyone see my screen?
Yes, we can.
Okay, good evening, everyone. My name is Matt Thompson. I'm one of the scheduling specialists at Styles Construction, and this is the presentation for construction scheduling. Let's go to next. So a little bit about myself. I'm a UFBCN class of 2000 graduate from the University of Florida. Also, I have, so that makes me have about 20 plus years of construction experience. Also, I am a local graduate of Broward County, Western High School. Let's go Wildcats, class of 96. So scheduling. Scheduling is a mindset. So there's two types of things. You have a red pill and a blue pill. So you have the red pill on the left, and you have the blue pill on the right. Red pill people kind of keep thinking that the project is going fine, just fine, dealing with the problems as they come up, and just trying to tackle them, day to day kind of thing. But the blue pill is always looking ahead to prevent and solve future problems from affecting the project. So that type of thinking so the red pill is more about a reactive. You're responsible for planning a surprise party for your friend. You figure out you have a lot of time since the party is a couple months away. You wait until the last minute to buy supplies and coordinate with everyone. The supplies you need are sold out. Then you blame the stores for not having what you need. You know what? And the result is that your friend has no surprise party. Being proactive, which is the blue pill side, You're responsible for planning the surprise party for your best friend. You begin planning months in advance and think ahead about anything that can go wrong. You plan to prevent any issues and or problems. And the result, you know, you have a very happy friend and a successful party. So what is a schedule? A schedule is a list of activities required to complete a specific goal or task. Each activity is assigned a duration in calendar or working days, and I'll go over that later on. All activities are logically connected to each other, creating a sequence to achieve a specific goal. And also there are softwares out there that is available to build a schedule and generate the start and finish dates for each activity. Now, the scheduling softwares that are available out there, currently we use P6. That's basically the the Oracle, no pun intended, of scheduling. Excel can be used for scheduling purposes as well. Microsoft Project, Asta Power Project, and Phoenix Project Manager. So let's go over some of the scheduling basics. The activity. Activity is the basic component of a schedule. An activity represents a specific scope of work with a unique activity name. Each activity, like I described before, is assigned a duration, indicating how long the activity will take to complete. And milestones represents the start and finish point in the schedule. Milestones have 0 durations. It's like a starting point saying go. And also duration. Duration is the length of time needed assigned to an activity based upon specific calendar. So what you're going to see right now is that I'm pulling up an activity and it has a specific duration. So this activity has a start and a finish, and that in between that start and finish is the duration. The next one is a milestone. A milestone has no duration, and it's commonly represented in most schedules as like a diamond, as you would see there. Calendars. Calendars, we all work 5-day work weeks. You know, that's what we know about, Monday through Friday. And as you see on here, the dates are shaded for Saturday, Sunday. And if you could look at September 1st, why is that shaded? That will be one of the questions you're going to get later on. So the next calendar that you see is a 7-day work week where there's no stopping. We work every day of the week. So that's what those calendars represent. And that's how we calculate time for these projects. So the scheduling basics continued. When properly created, the outcome is a critical path method schedule, a CPM schedule. A CPM schedule defines the longest path to complete a specific goal. So the activity relationships is what I'm going to talk about right now, and the logical connections between activities. The predecessor, an activity that occurs before another activity, and the successor is the activity that occurs after another activity. An example, you have 2 ends, 2 things that like the just like the party. The party, you had a start and you have a finish. So there's a point in time where you start planning, and then there's an end where it finishes, and the result is having a good time. So those activity relationships are tied together, and that's how you see it. So for this relationship is a finish to start. You see activity A is finish to start to activity B. So activity B cannot start until activity A is completed. A finish to finish represents activity B finishes at the same time as activity A. Then a start to start is activity A starting simultaneously with activity B. And then a loop, which is activity A ties to activity B, then activity B ties to activity C, and activity C loops back around to tie to activity A. This will cause an error in the system that would not allow you to continue with the schedule. Now, an open end is when an activity does not have a successor or a predecessor. So activity B goes to activity C, then activity C also connects to activity D downline, and activity E that is below it, which is a start-to-start relationship. So a schedule has only two open ends, a correct schedule. The first activity or milestone will not have a predecessor, and the last activity or milestone will not have a successor in a schedule. Total float. Total float is the days available before an activity pushes the completion date in a schedule. And a critical path activities make up the longest path to complete a schedule. So as a demonstration here, you can see that activities A and B are both 4 days. Activity C is 6 days. Where is the critical path going through? If you can't see that, then activity A and B together is 8 days. Activity C is 6 days. So that's the critical path. So activities A and B have 0 days of total float, and activity C has 2 days of total float. Since 8 days minus 6 days equals 2, so that's why activity C has 2 days of total float. And the critical path, as I stated before, is activity A and then activity B. And that goes to the scheduled completion milestone. So schedules in construction are always changing. Actual dates are recorded and future dates are reforecasted. And as an example for schedules, if anybody's been on an airline, they project out, your departure date, your arrival date, and you're booking your flight months in advance. And what they do, they use a schedule for that. They calculate how long it takes for a flight to get from point A to point B, and then they can calculate, okay, they do service of a plane, and then that same plane continues on another path, on another route. So every time it gets adjusted, that's why you see, oh, your flight was delayed. That means the next flights down line have been delayed. That's after you. The successor flights are delayed for that airline. As more information is available and changes to the specific goal are modified, the schedule will continue to evolve. And that's in a nutshell, meaning that once new information comes out, like we just had a pandemic that came through, a lot of manufacturing facilities have delayed our procurement. And procurement is when you order something that you get it, that will arrive on site. We do not have the ability of ordering things through Amazon to get it within 2 days, Amazon Prime, but because we're ordering large quantities and large pieces of material and equipment, so Amazon cannot help us out here. So the scheduling basics. So right here, as you see these activities, here's a baseline schedule, which are the brown bars. Now, as we record and move forward, we're seeing the blue bars as the current schedule. You see that July 7th, 3 days, July 9th, activity A, activity B, activity C, D, and E, so forth and so on. And this is a baseline comparison. This shows us where we have slipped. If you see the red line is considered the status date of the project, and every activity to the right of that red line is still in progress and can still change. But the activities to the left side of that line, those have not changed yet. And those have been actualized activities and they are confirmed dates. So when a schedule comes together, when a plan comes together, everything's coordinated. And in this video, I'll show you that this is a time-lapse video of a project that we've done here downtown, where once you coordinate everything and you see the time, it's just rolling. And everything's been coordinated to a T so that both of these buildings can go up simultaneously at the same time and complete at the same time. So Jacob, I'm going to hand this over to you unless anybody has any questions regarding scheduling, because scheduling is a proactive. Schedules do win projects. Time is money, And if anyone has any questions regarding this, I am ready and available.
Thank you, Matt. I am going to steal back the screen
Okay.
and first item I want to do is just to follow up real quick, everybody, on Matt's information on the schedule, and I want to show you a simple example of the level of detail in the schedule that we're looking for your project. So if your team is doing the Humanitarian Center or the School of the Future, some of you are doing a building edition of the future at your respective high school. But this is the level of detail we're looking for you to consider and to speak with your mentor in your respective high school to get input. This is a school project that my company did. This was an early on, very simplified approach to the schedule to identify the overall duration. Like, Matt maybe did not quite say it, but schedules can be multiple pages long for a large project with, hundreds and even thousands of lines or activities. This one is a very simple one. So this is one example, and we're going to be providing these examples to all the mentors and to the teachers, so you can have this as a reference. This is another one as well. This is another school project. Some of you already know, but my company that I work with do a lot of school projects. So a lot of the examples that I show you are related to school projects. So this is the level of detail. And then lastly, Matt, I believe you may have a couple of templates potentially that can be shared with students too, but
Yes.
Excel is a perfect platform for you to prepare that schedule. There's different ways of doing it on Excel, and the mentors working at your schools can help you with that, and we'll provide this and Matt's template as well for every team to utilize and develop a schedule for their project. So that's the last thing I wanted to show about scheduling. Okay, so let's talk a little bit about estimating. And here's the way we're going to approach estimating, guys. We can spend many days, many hours talking about estimating. We're not going to go into that level of detail. What I'm going to share with you is specific information that we want you to utilize for your projects and to do on your presentations, presenting your projects. So to start to talk about estimating, I want to introduce to you what you see on the screen right here. And the world of design and construction is organized by standards in the industry. There's a lot of different standards, but one of those standards is what we call CSI, which stands for Construction Specifications Institute. And before you look at the page on the right, what I want you to do is actually look at the bookmarks here on the left. And the Construction Specifications Institute organizes every type of building component, every type of material that can go into design and construction of a project into a 6-digit numbering system. And this is a very universal organization and standard within design and construction. And if you look at the bookmarks on the left here, you can see it starts from 6 digits of all zeros all the way down to 480000. And as you look at some of these main headings, starting with Division 03 is where there's concrete is covered, Division 04 is masonry, 05 is metals, 06 is woods, plastics, and composites. And then the list just goes on. Other big ones, when you get into the 20s, 21 is fire suppression. That's your fire sprinkler system that you have in buildings. Primarily, 22 is plumbing. 23 is what we call HVAC, heating, ventilation, and air conditioning. 26 is electrical. So I'm not going to read all of them, but I just want you to get an understanding for how the Construction Specifications Institute is organized and established. And then if I can click on any one of these bookmarks, like I'm going to go to 09, which is finishes, and you can see that 090000 is the main heading for finishes, but then there's page after page after page where that goes into a lot more details, everything from drywall to ceramic tile that you see here. And then it goes into all the details in tile. It goes into ceilings. It goes into flooring down here under 0960. So there's a lot of different types of components and materials that can be used on any given project. And they're all organized by the design team and then eventually by the construction company into these 6-digit CSI codes. So I want everybody to understand that background, and this document over here will also be provided to all the mentors and all the teachers and all the students for reference. The reason I gave you that background is now I want to show you this document, which once again will be shared with everybody. So what I prepared here is an allocation of a project cost throughout the different divisions, or known as materials, but divisions related to a project. And I specifically called it for a commercial building. And the reason I say that is because a school of the future or a humanitarian center fall under the category of a commercial building. So having cost data from my company, we created this allocation of cost throughout the different divisions. So if you have a project and you see the first one, everybody, under division 01 is what we call general requirements, and it represents for 15% of the project cost. General requirements include the construction company's staffing, people like myself who will manage and oversee the project. It includes logistics and general conditions that we need to have on a project in order to build a project. So what I mean by that is office trailers that you see on the side of a large construction project, temporary toilets for the workers to use, the temporary fencing that surrounds a project, usually for security reasons. Usually you'll see a lot of storage trailers on a construction project to store materials. Sometimes there's security guards, monitoring the project for security and theft. Those types of expenses fall under the general requirements. And as you can see here, they make up approximately 15% of the project cost. These are all approximate percentages, but they're very average and typical for many projects. Then as you go down the list here, concrete, masonry, and metals, what percentage of a project they usually account for. Division 6, 7, 08 is openings. That's your doors and windows. What percentage they account for. We talked about finishes. That's usually a high percentage of a project cost. That's where all of your interior work takes place. And I showed you some of those examples a minute ago when we went through the CSI process. So as I scroll down here, you can see here as I get into the air conditioning and the electrical, those are usually big cost items in a project. And how much do they account for? And also on the exterior of a project, you've got earthwork, that's your asphalt paving or concrete on the site, on the exterior of a project. We have utilities. We talked about that in our civil engineering classes about the storm drainage piping, water, and sewer to a project. So here we're showing you what those percentages are. Okay, so and once again, this document right here will be provided to every mentor, every teacher, and every student. So here's the next information I want to give you about estimating your particular project in today's dollars. Well, before I say that, let me just explain that construction cost is often discussed as a cost per square foot of your project. So square foot represents the size of your project. If you think potentially of your home, a lot of houses, houses range, most houses, I should say, range from about 1,000 square feet to 3,000 square feet, just on an average. So that's the size of a project and a house, I mean. So for our humanitarian centers, our schools of the future, one of the things we have to identify when we're doing our estimates for our projects is what is the size of our project. So all of you are designing your projects. They have dimensions, obviously. You need to identify what the overall area of your project is, and that will give you your square footage for your project. And then what we're going to do is we're going to apply a cost per square foot times the square footage of your project. So what I'm going to tell you is based on today's dollars, $400 per square foot is a good number for each team to use, either for your humanitarian center or for your school of the future. You are welcome, and I encourage you to do some of your own reading online, to speak with your mentors, to speak with other colleagues, and you are definitely free to establish a different cost per square foot for your project. But once you establish the cost per square foot for your project, and let's just say it's $400, you multiply that by the square footage of your project, which will then tell you your overall cost for your project. And then we will ask every team to use this document that you see here and allocate that cost to these divisions using the percentages that we have on the screen here. And once again, you are more than welcome to make some slight adjustments to any of these percentages. And you can speak to your mentors about this for guidance. This is a starting point, and you're able to use these percentages exactly if you choose so. But one specific example that I'll give you where you may want to consider making a change is, let's talk about Division 8 and openings. Openings, like I said, represents mostly doors and windows in a project. Possibly your project you're designing is 100% glass exterior walls, what we call a curtain wall system. And if your building is 100% glass on the exterior of the building, then guess what? The cost of your project related to openings is going to be a lot higher than 4%. It might be as high as 15% of the overall cost of the project, which then means you'll have to reduce some of these other percentages to account for that, because obviously at the end, and I don't have a total here, but it should equal 100%. So that is, generally speaking, what we want every team to do for estimating your projects. You need to identify the area of your project. I'm just going to summarize real quick. You need to identify the area of your project in square footage. You need to apply either $400 per square foot against that square footage, or establish what cost per square foot you are going to use and explain why. Once you apply that number and you get your total cost, then you have to allocate that total cost across these CSI divisions to show us the thought process of what different components and building materials are going to cost for your project. And you have this information here. I will also provide to you this information here, the breakdown of CSI divisions by the different division codes. And that is what we are asking for you to do, for each team to do, for the purpose of estimating your project. Before I go on to site logistics, anybody else on the call, any mentors want to offer input on that, or any commentary? Any thoughts on the $400 per square foot or a different number? I don't know, Stephanie, if you have some comments on that from your background.
No, luckily I leave a lot of it up to our estimators and our construction team.
Okay.
So,
Go ahead.
yeah, so just for rough, 400 bucks a square foot, $400 a square foot, and if you say it's a 3,000 square foot addition, just rough numbers, you're looking at 1.2 million. So just giving you guys a rule of thumb, just like, okay, whatever the square footage of your projects will be, you would have to use that. You could use that as a good measurement.
Absolutely. Okay, so the other item over the next few minutes here that we want to talk about a little bit is what we call in the world of construction site utilization, or sometimes site logistics is another common name. Kevin, who is on the call, is probably very involved with his role at his company, probably very involved in managing site logistics and the projects that he works on. Show you some just examples of what we'd like to see related to your projects. Kevin, if you don't mind, I may let you jump in and speak a little bit about it as well. But for example, and there's different approaches here and how to do this and the level of information to show, but this is a school project once again, and I've used this particular school to show other examples at Cooper City High School, which is the school that I mentor at. But this was a site logistics plan that we prepared. And we were building on this particular project, we were building the new building on the right side here that I'm circling right now, while the existing building was being occupied by the students. So in this site logistics plan, we're showing how we are going to manage the property and the project during construction. So we're showing how in many places we're going to put what we're calling double fencing to separate construction from students. We're identifying the primary construction entrance, where our construction trailer is going to be located. So someone like myself and other members of my staff are working out of this trailer over here. We're showing a secondary entrance. And since this is an active school, we're identifying how parents and buses are going to continuously access the property and the existing school while we're doing construction on the right side of this property over here. So once again, this is when we're doing construction, a big part of the process is just managing the project and managing the property over the 6 months, 12 months, sometimes 3 years, depending on the length of the schedule that we're on this project building it. We have to manage the property, whether it's an existing property with people already on it, such as a school, or whether it's a completely new property and nobody's there. There's still a logistics plan that we have to establish for managing the project. So this is one example. Here is another school example. This was a new property here. So there was no existing school. We're just building completely a new school. On this one, we're showing stabilized roads, which are basically construction roads around the building. This is the building in the middle. I know it's a little faint, but this is the primary building in the middle. So we're showing how we're going to build temporary roads in order to drive around the building so people don't get stuck in the sand. What we often call a lay down and staging area, which is where people are going to park their vehicles, workers, where we're going to store material, where we're going to have storage trailers and containers. We're also showing where our office trailer is. Once again, we identified a designated construction lunch area where we had tents located. People can come sit under the tents and eat their lunch. These yellow dots here are locations where we set up temporary lighting during construction for security purposes at night and to help avoid theft. We're showing the entrance into the project over here, et cetera, et cetera. So you can see here the thought process that goes into managing a construction site and a project during construction. And we want each one of our teams, again, whether you're building a humanitarian center or a school of the future, or more importantly, if you're building a building addition on an existing school, then this is very important, taking into consideration how you're going to manage that project during construction. So this is another example. And then lastly, and this one's a little bit more simplistic, but you can see this one was done on an aerial. So once again, this is a school. We're showing the perimeter fencing, which is the dashed red lines, a laydown staging and construction office location, a primary and a secondary entrance. So just different types of information, different details that we're identifying, depending on how much we want to show for that particular project. So this is another one of the deliverables when you look at the list of the deliverables for your project that we asked you to provide. So as it relates to construction, we want you to provide a schedule for your project. We want you to provide an estimate for your project, and we want you to establish a site logistics or site utilization plan for your project as well. Kevin, I can't see if you're still on, but if you
He's still
are,
on.
yeah, there you are. I mean, feel free to chime in and offer some commentary.
I mean, you hit all the high points, but just think of your site utilization or your site logistics as your picture's worth 1,000 words, where you're communicating one, to the estimator, which is a buzzword that Jacob, just went through in an estimate of how much of those construction roads do we need. And then you're also working with Matt, the scheduler, and telling them how long or how is your phasing cut up, because sometimes it's harder to understand a schedule when you're seeing what Matt was showing with the critical path and bars and dates. But almost everyone can understand some colored up drawings. And even if you put a date in there and start and finish, and you show on this floor plan what you need, you can communicate that from the ownership group. If you're on a renovation of a high school, hey, how long are we going to be using this one haul route to come through for parents to drop off and pick up? And you've got this one tool that you're talking to estimators, to managers, to owners, to schedulers, to craftspeople, just trying to build the job. So
Kevin,
there's
I was just going to chime in because you made a great point, and and I didn't cover it. Kevin hit it on the head. I mean, site logistics and utilization is something that's looked at early on, well before you start the project, and even while you're estimating the project. Like Kevin pointed out, because on certain projects, depending on how tricky the management of the site is going to be, this line for general requirements, which I'm showing is 15%. Might jump up to 20% or higher of the project cost if a big component of the project is tricky management and logistics of the property. So, I mean, that's a really good point, Kevin. I mean, this is definitely used in the estimating process as well.
And I do have a quick video I can show for that. Let me show you something. So as an example, let's see, screen
I
2.
stopped sharing that if you want to read.
Yes, I got it. Let me know if you can see it.
Yeah.
So with the power of VDC department, BIM, that we talked about last week, we do incorporate that. And when you said site logistics, as I play this video, you'll see the site logistics come to life on this project. This is a 12-month progress video to top out of a project out in Plantation. As you can see, the site fence going around, silt fence. We're starting to do drainage, just securing ourselves. You see our entrances coming in off the main road there. And as we start construction, some trades are starting to come on board. So that site logistics plan is very critical to make sure that we can maintain access to the site. As we're going, you see they're doing the underground right now, and all this has been planned out in the schedule from the beginning of the project. So as you can see, they're doing the drainage. We're starting to do some foundations, some concrete slabs are getting poured. And as you see this, as this video goes on, they're getting stuff ready to go. And now we have cranes. So now that increases our accessibility into the site, now that we have some hoisting capabilities within the building,
Look
within
how
the
tight
project.
the space is in the property too.
Yes. So as this drone flies around, it's overlaying all the pictures that it's done for the past 12 months. And you can see as the buildings start going up and you start seeing a project come together. So this is where site logistics and planning early on comes together.
And as you can see, guys, this is a great example of a really tight property where space is a premium during construction, and a person like Kevin and his role, you know, he's one of the generals out on a property, one of the superintendents, telling all the workers who can park where, who can store their materials where the crane is going to be located, where the fencing is going to be exactly, you know, and it takes people working for a general contractor to manage all of this and make sure it's an organized process and not just a disorganized mess. Because if it is disorganized and chaotic, that's how projects go off schedule and don't get completed on time. They end up costing a lot more money than they should. So it takes experienced individuals to manage the logistics of a project that will help ensure that it's successful. And we want each team, and you can choose how to do the drawing. You can either do it on the site plan that you're creating for your project, or you can take an aerial, like I showed you one example, to create your site logistics plan or utilization plan. Those two words are synonymous for your particular.
Yes. So is there any questions from any of the mentors, any of the, anyone that's on the line right now?
All right,
No,
good.
we did a good job, Jacob.
Yeah, we're right on the money with timing, huh? Okay,
Yeah.
so with that said, everybody, thank you for joining us for another one of our sessions in the virtual meeting portion of our ACE Mentor program. This one was on construction management. Good luck working on your projects at your next work session at your school. Looking forward to finishing your projects. We're close to the end of the school year, so everybody should be wrapping things up and working on finalizing their plans, because the next thing we'll have to be working on is preparation for your presentations. Thank you, everybody, and have a good night.
Thank you.
Thank you.
Good night.
Thank you.
Thank you, guys. Have a
Bye.
good night.